Hi, I'm Thomas Lee, the subject leader for INNOVA. For the last 2 lessons, we shared to you about the first 3 stages of design thinking, namely Stage 1, empathy, Stage 2, define, and Stage 3, ideate. So today we shall complete the whole process by introducing to you Stage 4, prototype, and Stage 5, testing. Okay, for Stage 4, prototype, we would like to introduce to you the concept of empathy prototyping. Now, a prototype can be anything. A lot of us thought that a prototype must be a physical model. That is not true, because a prototype actually takes any physical form, which includes even a piece of note, a role-playing activity, a space, an object, an interface, or even just a storyboard. So, an empathy prototype helps you to gain understanding about the design environment and the user's mindset about the offering. So, do make sure you have your end users in mind when you are creating a prototype. Now, let's watch a video to show us that even when designing a simple door, it requires a lot of thoughts to put into it so that your end user can be satisfied with it.
There's this door on the 10th floor of the Vox Media office that I hate so much. You ever get this door wrong?
Pretty regularly.
Have you seen people misuse it?
All the time, every day. Constantly. I hate this door.
Me too, Kelsey. But here's the thing. As soon as you start looking for confusing doors, they are everywhere.
It's push.
Why? I feel like Roman Mars would know about this.
This is 99% invisible, and those doors you hate are called Norman doors.
What's a Norman door?
Don Norman wrote the essential book about design. He is the Norman of the Norman door.
All right, and where is this guy?
You must go to San Diego.
Okay. Hi, Joe. Hey.
I'm Don Norman. It's hard to describe what I am.
Well, he's been a professor of psychology, professor of cognitive science, professor of computer science, a vice president of advanced technology at Apple. But for our purposes,
I was spending a year in England, and I got so frustrated with my inability to use the light switches and the water taps and the doors even, that I wrote this book.
If I continually get a door wrong, is it my fault?
No. In fact, if you continually get it wrong, it's a good, and if other people continually get it wrong, good sign that it's a really bad door.
a Norman door is one where the design tells you to do the opposite of what you're actually supposed to do, or gives the wrong signal and needs a sign to correct it.
Why does it need an instruction manual? That is, why do you have to have a sign that says push or pull? Why not make it obvious?
It can be obvious if it's designed right.
There are a couple of really simple, basic principles of design, and one of them I'll call discoverability. When I look at something, I should be able to discover what operations I can do.
The principle applies to a whole lot more than doors.
And it's amazing with many of our computer systems today. You look at it, there's no way of knowing what's possible. Should I tap it once or twice, or even triple tap? So discoverability, when it's not there, well, you don't know how to use something.
Another is feedback.
And so many times there's no feedback. You have no idea what happened or why it happened.
And these principles form the basis of how designers and engineers work today, commonly known as user or human-centered design.
I decided at one point the word user was a bit degrading. Why not call people people? And it's amazingly simple and amazingly seldom practiced. We call it iterative because it sort of goes around in a circle. We go out and we observe what is happening today. We observe people doing the task. And from that, we say, oh, we have some ideas. Here's what we should perhaps propose to do.
Then you prototype your solution and test it.
Quite often, these are wrong at first. But each time we go around the circle, we do a better job of making the device until the point we're actually making something that really works.
And this process has spread all over the world.
And it turns out it's improving lives.
From better everyday things like the ones that Don wrote about,
to using the same process to solve huge problems in public health in developing countries.
Water,
sanitation,
farming,
lots more. So what'd be a better human-centered door?
An ideal door is one that as I walk up to it and walk through it, I'm not even aware that I had opened the door and shut it. So if you had a door which had a flat plate, what could you do? Nothing. The only thing you can do is push. So see, you wouldn't need a sign. A flat plate, you push.
This kind of push bar with the piece sticking out on one side works well too, so you can see what side you're supposed to push on.
The vertical bars could go either way. A simple little hand thing, though, sort of indicates pull.
But we still have terrible, terrible doors in the world. So many of them.
There are lots of things in life that are fairly standardized, and therefore, whether I buy this house or not is not a function of whether it has good doors in it. And so, except for safety reasons, doors tend not to be improved.
But the tyranny of bad doors must end.
I think that it's a really shitty design. The fact that they put a pull handle when it's a push. And it should be a flat panel right here. And not a pull handle. That's how I feel about the store. It's very misleading.
I agree.
You're right, Becky. You're goddamned right. And if we all thought like you, well, we might just design a better world together.
It won't open because it's a security door.
What are you two doing?
Hey, so as you can see, since I started making this video, they've since changed the door a little bit. I guess it's a step in the right direction. Thank you so much for watching, and
I hope you enjoyed the video. So do remember, the purpose of doing a prototype is to help us eliminate ambiguity, assist us in our ideation process, and also reduce miscommunication between the designer, which is you, and your user. In fact, we can make fantastic prototype even with very, very simple material, just as what this next video is showing.
Do we have a name for it? Toasty. Toasty, the interactive toaster. Hi, my name is Andrew Brace. I'm a prototyper here at Quirky. We have 3D printers and CNC machines, but whenever we first start to prototype our ideas, we typically use materials as simple as cardboard or paper, things that you'd have at home. It's cheap and easy to be able to get a sense of size and scale and form, and it's just a very approachable material. For the sake of illustrating our prototyping process, we decided to create an interactive toaster. It has a touchscreen that allows you to draw your own design, and it will replicate that design by burning it into your toast. Before you jump straight into it, it's always a good idea to try to sketch out your idea, to figure out roughly the size and shape of it, and also give you an idea of how much material you're going to need and how you might approach cutting and gluing and things like that. We start off with a box, as simple as possible. We cut out our 6 sides, we taped them together, figure out some of the details and the size and scale of the knobs and the screen. After the first model, we had a better idea of what we wanted the final prototype to look like. We were able to use less pieces, which you end up having a more refined looking model because you don't have as many part breaks. In order to achieve these rounded edges, I incorporated a technique called scoring, where you cut just the surface but not quite all the way through, and that lets you bend the material in various ways. The lever detail on the side of the toaster, the design called for a round knob, and to achieve that in cardboard, we basically cut a series of circles that got smaller as you went towards the outside and stacked them up to build up the 3 dimensions. It's actually really challenging to cut a curved line into a piece of cardboard. Instead of trying to take it all at once, you make several small cuts to round out the edge. The whole purpose of prototyping is to get that idea out of your head and put it into some sort of format that other people understand. With a little thought and creativity, you can convey any idea to anyone, and it helps you make informed decisions about your refinements later on in the process.
Mentioned earlier, prototype may take many forms, not only physical model. It can be a role-play activity, it can be even a piece of note, it can be wireframing, which is used for mobile apps. Now for wireframing, your makerspace coaches will explain this to you in detail. You can even create a storyboard as your prototype. Now what is a storyboard? A storyboard is whereby you create a very simple story on paper to show the problem and how your idea can solve that problem effectively. Since it is a storyboard, you must tell that in a story format. Okay, so make it interesting. You need not be an artist to draw a nice storyboard. Even stickman will do. Temasek Polytechnic actually provides a very conducive environment for all students to create their prototype. And it is free. So do visit our makerspace to find out more about the equipment and support that we have for you. In one of the lessons, our maker coaches will also come to your e-tutorial session and explain to you more about Makerspace and how to create your prototypes.